Okay, here in this second VI, we need to make the lab view to do the job automatically. Instead of inserting the volt one by one and take the output, I would make the lab view to do this automatically. So here I will add some more steps to what we did. Okay, so this is our sequence last time. Here, to make it automatically, I need for loop. So the for loop, of course, need a counter. So this counter also will be counted automatically based on the step that you want our resolution here. So V minimum and V maximum, V minimum and V maximum will determine, with the step will determine how much time you need to run this loop. For example, if I have this 0, start 0, and this is 10 volt, so you have 10 here, divided by the resolution, which is, assume the resolution is 0.5. So 10 over 0.5, you have 20 points. So 20 points, and to avoid starting from 0, we start from 1, we add 1 here, so this will count. So here we have 20 counts to run the loop. The loop will run for 20 times in this case. We'll take the V minimum, which is 0 in this case, the first case is 0, and then multiply the resolution by the index of the loop. Okay, so my resolution is 0.5, and the index is 1 in this case. So half times 1 is half, okay, plus 0, you will just have 0.5 here, and then this will be your input volt, and also will take into the XY graph, as we'll see inshallah. And then it will calculate the output. It will go, this input and the output will be merged here in this merge, and then will be written in this measurement file. This measurement file, we save the data under this direction, under this directory, sorry. Okay, so it's called test.xl, as you can see here. The gain is always the relation between the input and the output. So we divide the output over the input, we got the gain, how much gain it calculates. Vs here represent the V input, the current input of the loop. And then we take the input volt as x-axis by creating build XY graph. Build XY graph, we take the input to XY, we take the output to the y-axis, and then we can generate the graph. To run this VI, what we need to do, we just set the maximum, say 10 volts, and minimum, say 0, and the step here, our resolution here, will be 0.5. Then I will run. Stop here. I guess this is continuous. This problem because of the data acquisition card need to be reconfigured. Remove and add. Okay, now run. You can see what happened. Oh, still here. Still the file is open, I guess so. Need to close it. Don't save. Now we need to just run. You can see we got the curve. Very quick, very efficient. We got the curve. Okay, so if we want to see the measurement file, so we'll go under this directory, lab view, user, documents, lab view data, and you can see the file is called test. Okay, so here you can see the values. Then you can just highlight this value, insert scattered graph, and then you can show the equation by add trend line, show the equation, show the r square, and this will be our equation. As you can see here, the equation showing that the relation between x and y, x always half of the y, and the r square is 1 because we fit all the points. So this is for the VI number 2. It's automatic VI that can calculate the input by itself and then generate the curve at the end. That's all for today. Thank you very much.